All right, everybody. For this video, we are going to talk about how do we keep track of our significant figures and how many significant figures should we have when we start to do calculations with values, with the measurements that we take. So for number one, I am given a perfect cube of iron with a side length of 7.62 centimeters. And I am asked to calculate the density of my iron if it has a mass of 3,483.9 grams. And then I also need to figure out how many significant figures should my answer have. We'll get rid of this little typo here. So remember that density is mass over volume. So if I want to calculate the density, I need mass and I need volume. Lucky for us, we already have mass, but what we do need is volume. But because this is a cube, we know the volume of a cube is the length times the width times the height. So we know we have a side length of 7.62 centimeters. So I'm going to take this value and I'm going to cube it. And when I put that into my calculator, that is going to give me 382.657176 centimeters cubed, because our units change the way we do the math. I'm not going to round this number until the end. Any numbers I have in the middle of a problem, I'm not going to worry about significant figures. I'm going to leave them unrounded because I don't want to introduce what we call rounding error. So now I have my volume and I know my mass. So all I'm going to do is I'm going to find that my density is my mass, 3,483.9 grams, divided by my volume, 382.657176 centimeters cubed. And I'm going to put that into my calculator. 3,483.9 divided by my volume. This is where I need to round. This is where I need to ask myself, how many significant figures should my answer have? If we look, the math that we have done is division here and repeated multiplication here, which means my answer has to have the least number of significant figures that are present with the numbers that I'm using, the measurements that I have. So the two measurements that I have that I then did math with was this 3,483.9 value and this 7.62 value. If I look, 3,483.9 has 5 significant figures, but 7.62 only has 3 significant figures, which means my final answer, I have to round to 3 significant figures. So once I go back to my density and I see what I have in my calculator, I should round my answer to 9.10 grams per centimeter cubed. Now let's try another one. You are going to carry out a chemical reaction in which you need 16 grams of oxygen for every 7.0 grams of nitrogen that will be used. If you have 0.554 kilograms of oxygen, how many milligrams of nitrogen do you need? And how many significant figures should my answer have? So take a breath. I know there's a lot of information in this problem, but this is just a unit conversion problem. So if I look at this, I'm given 16 grams of oxygen for every 7.0 grams of nitrogen. This is really a ratio. 16.0 grams of oxygen to 7.0 grams of nitrogen. And in a problem like a unit conversion problem, when we are multiplying ratios, multiplying fractions, that makes sense. That's really a conversion factor in disguise. What I also need to look at is the fact that I have 0.554 kilograms of oxygen. That's my starting amount. That's where I'm going to set up my first fraction. So now my end goal is milligrams of nitrogen. And if I look, my bridge to get from oxygen to nitrogen is in units of grams, which means I'm going to convert my kilograms of oxygen into grams of oxygen. Now I know that for every 1 kilogram, I pick my bigger unit, give it the 1, I have 1,000 grams of oxygen. So that gets me to grams of oxygen. Now I'm going to convert between my substances. I know I want to get rid of grams of oxygen and I want to get into grams of nitrogen. How many in each? I go back to my problem. It tells me for every 16 grams of oxygen, I get 7.0 grams of nitrogen. Now, I do it one more time. I want to be in milligrams. So I want to cancel grams of nitrogen. I want to get into milligrams of nitrogen. These cancel, and these canceled before. I just forgot to cross them out. I pick my bigger unit. 1 gram is bigger than milligrams, so I give it the 1. I know milli is 1,000 on the small side. So 1,000 milligrams in 1 gram. So now I'm in milligrams of nitrogen. That's the unit I want to be in. Which means I'm going to do the math in my calculator. 0.554 times 1,000 times 7 divided by 16 times 1,000. And that's going to give me my final answer. Now the question of where I round it. Again, we are doing multiplication and division. And so we pick the number, the value, the measurement that we care about with the least number of significant figures. Now technically, here we only have 1 significant figure for this as well. But these conversion factors are exact. So we say that they have infinite significant figures. Now I look, this number has 3 significant figures. This one has 2, and this one has 2, which means 2 significant figures is my least amount, and my answer has to be rounded to 240,000 milligrams of nitrogen.